Okay, so let's continue with our analysis of digital pictures using Python, in particular the PIL or PIL library. And so basically in the previous video, I explained a little bit about, well, the idea that there are some pixels on this, that make this picture, that digital pictures. And so let's go a bit more in details about what are pixels. Actually, in digital pictures, pixels are so those little touch of color, if you want, are attributed three channels that are called red, green, and blue channels. Basically, there will be some numbers going from 0 to 255 attached to each of those three channels. So I have put a little image here just to try to explain you, like if you want to produce a color which is like that, something maybe, I don't know exactly where it would be like, but this type of color that you see, well, you know, in digital pictures, what you need to understand, well, I mean, even in non-digital pictures, okay, colors are a mixture of red, green, and blue, and this color in particular is in digital picture provided some values for the red, the green, and the blue channel. So you see 95, 117, and 48. And those numbers, each of those three numbers can go from 0 to 255. Of course, you know, when you communicate with machine, with computers, those numbers are eventually translated into binary system, but we don't need that for the time being. And you can see here there's some kind of computation that has been done. R in this color is basically viewed as 37.3% of its potential R. So I think that what, you know, this operation here is you take 95, you divide it by the maximum that the red color could be, 255, and that gives you 37.3. And so you can think of that as the intensity of the red in this color. And you can do that with the green and the blue, the same kind of operation. Actually, there is also another way to do it. If you take the summation of those three numbers, you see that they do not add to 100%. So actually, what people are also doing is the following: like they take this number here and they divide it by the summation of those three numbers, which gives, you know, it's another way to see what percentage of R of green and blue there is in this color here. So you see those numbers here. So it's slightly different from that. It's another way to understand the problem. So in order to understand a bit more those three channels, okay, let's basically create a picture from scratch using the PIL library. And you know, we are going to use the image module, and in that image module there is a function that is called new, and the new will actually create a new picture, okay? And basically you want to include some parameters for this new picture that you are creating. The mode is equal to RGB, so you indicate that actually you want to create a red, green, blue channel picture, okay? The size, well, you know, this means that there will be 100 pixels along the X dimension and 100 pixels along the Y dimension. And total number of pixels in the picture will be 100 times 100. So it's 10,000 pixels. And basically, let's choose those numbers that we have put: 95, 117, and 48. So that is for the value of the red, the green, and the blue channels. I'm creating this a new picture here on the right side of the equality sign, and I assign that to a variable that I call EMG2. And if I repeat EMG2 and I run this, I'm gonna get this square. So actually this is a square, okay, and look, that's the same color as this one. This is a square, and there is actually 100 pixels in that direction, 100 pixels in that direction, and altogether 10,000 pixels in that little square. I can save it if I want, and give it a name, green square, GPG, then it should, you can see it here. And well, imagine that I want to create a new picture from scratch, but this time it should be black. Okay, what should I do? Okay, well, actually, instead of having 95, 117, and 48, I should have 0, 0, 0. As black is the absence of color, so it's 0 everywhere. Okay, so if I redo the same operation, I'm gonna get a square which is all black. Of course, I can have it all white. And if I put 250, 255, 255, 255 here, I'm gonna create a small square, which is all white, okay? Of course, white on white, you will not see it on the screen. So I'm gonna put it a slightly smaller value than 255. I put 250 and I run this. And you see it's very pale, okay? If I put 255, 55, 55, it would be totally white, so you wouldn't see it. Try by yourself. If you want to have a red square, okay, you would pick, well, actually I should have put 255 here, and then 0, 0. So remember, the first number here refers to the red channel, the second number refers to the green channel, and the last number refers to the blue channel. So you don't want to have any green or blue, but you want to have a maximum intensity of red. So that's what you would get. So let's come back to our initial image now. The one that I created before using those values here that you see. Using those values, let me create it again once. And actually, when you work in Microsoft Word, actually you get the same. I made a screenshot here. Okay, so this is what I copy paste from. I copy paste this, and then I paste it in the Microsoft Word page, and then basically I have tried to redo it in Microsoft. So in Microsoft, what I did is simply to create a text box, and then I fill the interior of the box with solid fill, and then I choose a specific color. So you can go here, and then you pick the color 95, 117, and 48, and you press OK, and it will give you this thing. In case people, I know that most of you have not worked a lot with digital print image processing. But those numbers here now should have a better, you should have a better understanding of those numbers. There is also an X number. I will come back to that slightly later. So try it using Excel. I think I still have this thing open. See, I created a using this insert text box. I created a text box like that. And then you go here for shape option for fill. And you can say, well, I want a specific color and I want to custom and to use 95, 117 and 48. And you press OK, and here it is. Okay. So try to experiment a little bit by yourself with this. Now, from this image that I have created here, EMG2, let's crop only one pixel, the one that is exactly here. Okay, so I position myself at the top left of the image. So that's the 0, 0, that's what that means. And then I go 1 pixel in that direction and 1 pixel in that direction. I'm gonna crop this part here of the image. If I run this, and I ask Python to show me, well, this is so small that it's here, but you don't see it, okay? Now, imagine that you wanted to discover the value of that pixel here, okay? What could you do? It's a bit like the reverse operation. You can, if you have some values for red, green, and blue, you can create pictures. But if you have a pictures, you can always ask yourself, but what are the values underlying that pictures? So in order to do that, you should import a new library. It's called NumPy. It's a very important library. It is so important. It's numerical Python. It's so important that actually it's already pre-installed in your Google Colab environment. And you simply have to import it. So click on this. And then using that NumPy library, we are going to use the function array. Okay, and you apply that function. Well, you pass the argument of what you just cropped here. That's that tiny dot that you hardly see on your computer. So if I pass this, okay, yeah. If I pass this cropped image, and this thing here, I assign it to a new variable that I call data, and then I write data again, it should give me the values of that tiny pixel. It tells me, well, it is composed, actually, that tiny dot is composed of 3 values, 95, 117, and 48. Of course, I could crop a slightly bigger slice of the initial picture. So instead of taking just one pixel, I could crop 10 pixels. Okay, and if I crop 10 pixels, so I'm taking a slice like that. I'm going from the top left, and I'm going 10 position or 10 pixels like that, and 1 pixel like that. So I'm cropping this part here. If I do that, I can run this thing. And now you see that I have a bigger slice. The image is slightly bigger. And I can again try to get, well, what is the values of those red, green, blue channels. And I will use again the array function of the NumPy library. I pass as argument of that function this new cropped image. And I assign all that to a variable that I call again data. And I run this, and now you can see that actually I have indeed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times three values. The three values that you see here are actually the values for the red, green, blue channels of the first pixel, this one here, and then the second pixel, this one here, and then the last pixel, this one here, okay? And I can, increase, okay, if I crop uh, 10 pixels along the first row, but 3 pixels along the the y dimension, I'm gonna get a bigger segment. And so I can redo that 10 by 3. So I'm gonna get actually this image here is actually composed of 30 pixels. And if I want to have their values, I can again use the same trick as before. And you see, so that's the first pixel, which is on the first row. This is the second pixel, which is on the first row, but in the second position. This is the 10 pixel, which is in the first row on the last position that you see here. And then you can see that you have a second block for the second row and a third block for the third row. Okay. All this will become a bit more useful later on when we will do something with that. So let's go back to the original picture of the dog. Okay, so I can, again, I use the open function. I pass the argument, okay, the name of that picture, and I assign this expression to this variable. So this now basically has saved, if you want, the picture, the original picture, and I'm gonna crop it and take a segment. So 10 pictures, 10 pixels along the x-axis and 3 along the y-axis. So I'm cropping a area of 30 pixels. And that's what I get. And now remember, now we are on that, not on this picture, but on the picture of the dog. Yeah, I don't have it here, but and the legitimate question is, well, what are the pixels values for red, green, and blue channels besides this picture? Okay, so if I do that, I'm gonna get those values. And you see that now, well, those are different values from that, because those are actually the values of the pixel for the image of the dog. Maybe if I type EMG, I should have the image to give me back the image of the dog. So, the values that you see in 3164 tells you that the first pixel here has a numerical value of 31 for the red channel, 60 for the green channel, and 4 for the blue channel. So there is very little blue here. It's a mixture of red and green, which gives you this color here. And okay, so now that I would like to show you as well that when you create a picture, instead of giving you still need to provide the mode red, green, blue, but you can provide the X values. Remember X, H, EX, that's what you see here in the um, this is the X value that you see here. And see, I took this value here, okay, and I simply passed it here. And so I create again an image from scratch using the red, green, blue mode. 200 pixels along the x-axis, 200 pixels along the y-axis. And the color, instead of providing numbers for red, green, and blue, I simply provide the X numbers. And this is what it gives me. So same as before. You can also use the name of the color. And if you put pink, for example, you get this thing here. There are different color names. So those are official color names. Of course, there are less official color names than combination of color. And that's why I cannot really provide a name for this color because it's in between different type of green, right? But I put some name here that you can try. So all what you would need to do is to replace this with this and observe what it gives you, like Control D. And that's what it gives you. Okay, and also I have provided not only the name of the color, but I have provided a picture which shows you the color per se. See, aquamarine, I just picked that, and that's basically what it gives me. Okay, it seems to me a bit different from this picture, but and I would like to also introduce you to something which is called the alpha channel. Up to now, we have worked with a mode that was called red, green, blue. But sometimes you are going to see a mode that is called red, green, blue, alpha. And the A that you see here is for the alpha channel. And basically, well, the size of the picture that we are creating from scratch is also 200 pixels along the X and the Y axis. And the color here, you can see that I take the same values as before, 95, 117, and 48, but I have added a value for the alpha channel. So that value can go from 0 to 255. If you put 255, it means that what you are creating is a totally opaque image. Okay. But if you put on, you may want to save that, this image that we just created. Okay, so let's try to save it under the name green underscore square one. So, like it's EMG4, that's object EMG4. So I want to save EMG4. I give it a name and I give it an extension. If I do that, you are going to see that actually there is a mistake, okay? And the reason there is a mistake is that the JPEG format does not allow you to introduce a alpha channel, okay? But you can save it as a PNG file, okay? So if I save it as a PNG file, I will get a new pictures here that is saved as a PNG file, okay? Of course, you can decide to use a lower value for the alpha channel. So, for example, well, if you push it to 0, you are going to have an image which is totally translucent, transparent. Okay, and you see that as well. Huh? You have something here, transparency. Okay, you can either put a maximum 100% of transparencies or 0%. When you put 0% here, it's opaque. And that's our 255 that I have introduced before. And if you put, I guess, 100%, it's totally translucent. Okay, that's, I guess I can try it, but That would be totally translucent. And you can try it. I haven't tried, but of course, you know, if I put something transparent on my screen, you are not going to see it. So instead of putting a 0, I have put a 60, and you can run it, and that's what it gives you. So it's still those colors, but the image is more translucent, more transparent. And yeah, I did it with the 0, so if I do that, you don't see anything. Of course, up to now, we have worked with two modes, RGB for red, green, blue, or RGB A for red, green, blue, and the alpha channel, which basically control for the transparency of the image. You can also work with images that are called grayscale. And grayscale images are basically image which goes from 0 to 255. There is only one channel if you want. There is not three channels. And there is only one channel which goes from whose values goes from 0 to 255. You know, here, so basically here I put 150 for example. You can see that I have produced an image which is gray, okay, and of size, you know, 15 pixels on the x-axis and 5 pixels on the y-axis. Again, as before, you can, when you have an image like that, you can ask yourself, well, you know, what is the pixel values in the grayscale image? What is the pixel values? And so if you do that, and you apply that function on the image that we created, and you see this table of numbers. So clearly you see 150 everywhere. And you can see that there are 1, 2, 3, 4, 5, actually 15 pixels along the x-axis and 5 pixels along the y-axis. Of course, you know, instead of gray, you can, if you push that value to 0, you are going to generate a black image. That's this thing here. And if you push it to 255, well, you know, it's going to be a white image that you don't see, of course, on the screen. White on white, you cannot see it. So I'm going to stop here for the second part of that tutorial. And I will come back for the third part of the tutorial in the next video.